On today is domain and range of a function. So this is the first thing from the third quarter, basically. And I think you're going to pick it up pretty quick. We're going to start off with notes. So domain and range of the function is the topic. And we're going to start off with the blank of f of x is the set of input values. So that would be the domain. So the domain is what we're plugging into f of x. So input values mainly means the x's. So the domain are the x's that we're plugging in, as opposed to the range of f of x, which is the set of output values. So the range would be the y's or the answers that we're going to get. So that's the difference between domain and range. Domain we think about as the x's. Range is the y's. All right, now, the whole topic boils down to this sentence. The domain of a function will always be all real numbers, unless it's a radical or a fraction. So if I go, what's the domain of this? Look at it. If it's not a radical and if it's not a fraction, then the domain is going to be all real numbers, meaning we can plug in any number we want. Now, this year, when you give me domain and range answers, we're going to use something called interval notation. And the interval notation for all real numbers would be negative infinity to positive infinity. And we're going to use soft brackets because you can never reach infinity. We use, let me show you the difference between the brackets. Let's say I'm going to write negative 3 less than x is less than or equal to 5. Right? Let's say this is the situation we have. In interval notation, the way we'd write it is soft bracket negative 3. So soft bracket means we're not actually using the negative 3 because there's no line underneath it. But notice there's a line here, less than or equal to 5. So we do comma 5 soft bracket. So anytime it's equal to, we use a solid bracket. And anytime it's just less than or greater than, we're going to use a soft bracket. And again, we use a soft bracket for infinite because we never reach infinity. All right, so here we go. We're just going to do a bunch of examples here. And then I'm going to have you try a bunch of different worksheets with these and I'll check your work. So what I want to do is find the domain. So we're only dealing with the x's. We're going to do range, just a little taste today. That's about it. So if I ask, what's the domain? Look at the equation. Is this a fraction? No, it is not. Is that a radical? No, it is not. That means the domain is going to be all real numbers. Nothing will ruin this. Or we could plug any number we want in. So let's think about what it looks like when we graph it. What would this be? And I'm hoping you're thinking it's a line. And if you think about when you graph a line, right, it looks like that, a diagonal line. It goes on forever with no obstacles. Okay, so take a second here. G of x equals x squared minus 5x. What do you think that domain will be? Good, all real numbers. It's not a fraction, it's not a radical. So all real numbers again. Now that's not really how you make the infinity symbol. The infinity symbol is supposed to look like that, but mine starts getting really sloppy, so I just do the double zeros. What would this look like if we graphed it? And the fact that it's an x squared means it's a happy face parabola, right? And that would go on forever. So it's a pretty little graph. All right, what do you think this one is? Okay, this one is going to be all real numbers as well. It's not a fraction, it's not a radical. What would this look like if we graphed it? Right? This would be a horizontal line like that across 10. So again, because it's a line, all real numbers. All right, here we go. Now we have a fraction. The fact that it's a fraction means it is not going to be all real numbers. So when you have fractions, what you want to do is put all your attention in the denominator. What number can we never have in the denominator? And that is 0, right? So if I plug in a 5 here, 5 minus 5 would make 0. That's bad. So anytime you realize it's not going to be all real numbers, what you're going to do is you're going to draw a number line. And you're going to say, what number would ruin the denominator? Right? 5. I want to put an X over it. It means we cannot plug in a 5. Now, after you write in your numbers, what we're going to do is start testing. Plug in a number bigger than 5, like 6. 6 minus 5 is 1. You could do that. So that means we can go above it. Plug 4 in. 4 minus 5 makes -1. You can have negatives in the denominator. That's fine. So that means everything works except 5. So the way we write this answer is we can go down forever. We can go towards negative infinity until we hit 5, soft bracket. And I made it a soft bracket because we can't have the 5. Or, and instead of the word or, we're going to use the union symbol. We could go 5 and up. So that's what the domain would be for this guy. And that's what we're going to practice a whole bunch of now. So now let's take a look at this guy, number 5. All right, notice it's a fraction. So in step 1 for fractions, what we're going to do is, now the numerator doesn't matter to me. It's just the denominator. And what I'm going to do is factor it. Okay? Now, in this situation, 2 numbers can make it a 0 in the denominator. Now, another hint, see how it's x squared? That means there should be 2 things. In the last one we did, this is x to the first power, so only 1 number ruined it. So the exponent will give you a hint. So, I'm going to draw a number line here, right? This time, a positive 4 would ruin it, and a -3. So we can't have that, we can't have that. Now, we're going to test, right? 5 minus 4 is 1, 5 plus 3, right? That's fine. Right? You could plug 0 in, right? And you could go below it. So in this situation, the only things that are going to ruin it are the 2 things that make the parentheses 0. So this domain now, down forever, means from negative infinity to -3, so we have that interval, or anything between these guys would work, or 4 and up. Okay. Now, let's get number 6. 6 is a fraction, but if you notice, in this one and in the last one, see how there were x's in the denominator? Do you see any x's in the denominator here? No, we don't. And that's because this can be rewritten as 1/5 x minus 4, right? So it's actually not really a fraction. So when I mean a fraction, I mean there's got to be a variable in the denominator. This is actually just a line, right? If you distributed this would be 1/5 x minus 4/5. And if it's a line, that means the domain is going to be all real numbers. Okay, now let's look at number 7. We have a fraction, right? There's an x in the denominator. That's a problem. Can we factor this? No, we can't. This denominator is unfactorable, right? There's nothing we can plug in here that would make this 0, right? If I plug 0 in, 0 squared plus 1 is 1. That's okay. What happens if I plug in -1? -1 squared is 1. 1 plus 1 is 2. Right? Nothing will make this denominator 0. So since no value will make the denominator equal 0, right? The domain is going to be all real numbers. Nothing can ruin this. Nothing can make a 0 in the denominator. So we're good. All right, so now we've talked about fractions. Now we're going to talk a little bit about radicals. And the easiest way to start radicals is what would make a 0 in there? And I'm hoping like a 2. So that's going to be our starting point. We're going to start with the number 2. Now, plug 2 in. 2 minus 2 makes 0. Can we take the square root of 0? Yes, we can. It's 0. So that means we're allowed to have the 2. So I'm going to put a solid dot over it. In a radical, it is okay to have a 0 inside the radical. So that's why I'm putting a solid dot. Now let's test around it. Plug in the number 3. What is 2 minus 3? I get the square root of -1. What is the square root of -1? That's I. We cannot have imaginary numbers in this. So that means what I'm going to do is put a sad face here. We don't want to go towards there. Or you can put an X. We can put either one. Most of the kids like sad faces better. So we're not going to go towards the sad face. Now, plug in 1. What's 2 minus 1? What's the square root of 1? So we got an answer. So that means we can go that way. So the domain for this question is going to be -infinity up to 2 solid bracket, because we're allowed to plug in the 2. It's a solid dot. All right, number 9. Let's take a look at this. So just like in this one, you want to say to yourself, what number or numbers, if you plugged it in for x, would make it 0? I'm hoping you're thinking 5. But also -5, right? -5 squared makes 25. So again, like last time, what exponent did this guy have? A 1, so only one number to worry about. Notice this is x squared, and we have 2 numbers. Now again, in radicals, you can have 0. So I'm going to put a solid dot on that. And now I'm going to test around the numbers. Plug in 6. 6 squared is 36. 36 minus 25 makes +11. That's good. So we'll draw an arrow up. All right, plug in a number between these two. How about 0? 0 minus 25 is -25. We don't want negatives, so we're not going to go there. Now plug in -6. That makes 36 again, which will give us 11. All right, so my domain is the arrows. So the domain for this is going to be -infinity to -5 solid bracket, because it's a solid dot, or solid bracket 5 and up. Okay. Check out this one now. What number, if you squared it, would make this 7? It's going to be radical 7, right? Radical 7 squared makes 7, and then you get 0. But since it's a squared, there's a +7 as well as a negative radical 7. And since it's a radical, we can have these. So I'm going to put solid dots. Okay, now we're going to test. Pick a number bigger than radical 7. It could be any number, like 10. 10 is bigger than radical 7, right? 7 minus 10 squared, ooh, that would be a big negative, so I'm going to put an X. Plug in an easy number between them, like 0. What's 7 minus 0? 7. That works. I'm going to shade it. And then plug in like -10. That's not going to work either. So my domain for this one is going to be solid bracket negative radical 7 up until 7 solid bracket. All right, number 11. Now we're going to mix the radicals into the fraction. All right, so all of our attention is going to go here. What number would make this 0? -9. Right, so we draw my number line. Put a -9 on it. Now, here's the difference between the last one and this one. When the radical is not in the denominator, right, this would be over 1. If the radical is in the numerator, you can have 0. However, this radical is in the denominator, so we can't have 0. So we can't have that. And now we're going to test on either side of it. Plug in a number bigger than -9. How about -8? That makes +1 inside the radical, so we're all set. Plug in a number smaller than -9. How about -10? Uh-oh, that would make a negative in the radical, so that's no good. So this domain is going to be soft bracket, because we're not allowed to use the -9, up until infinity. All right, number 12. Number 12 is the cubed root of x minus 5. Right, so you're starting here, right? 5 minus 5. That would make 0. And we're allowed to have it because it's not in the denominator. Now we're going to test. Plug in a number bigger than 5, like 6, right? What's the cubed root of 6 minus 5? So what's the cubed root of 1? 1, all right? So that worked. So we're going to go that way. Plug in a number smaller than 5, like 4. What's the cubed root of negative 1? Hey, wait a minute. There's an answer for the cubed root. That's negative 1. So everything works. So this domain is all real numbers. Now there's a trick to knowing this. Notice this is a cubed root. You can take cubed roots of negatives, which means you don't ever have to worry about anything. So as long as you have a cubed root, a fifth root, as long as this index is odd, it will always be all real numbers. However, if the index is even, like this one, 4, 2, 8, then you have to have positives only in there. So this one, you have to handle like a square root. In this one, I would say 5. If I plug in 6, I get a positive 1. But if I plug in 4, I get negative 1. And since the index is even, I can't do negatives. So this domain is going to be solid bracket 5 and up. Okay, so what I'd like you to do now is see if you can do these 3. So pause me for a second and give these 3 a try. Let's see how you do. Okay, so I hope you pause me. And what you should have done first here is factor your denominator. Okay, so I factored it. So the thing that are going to ruin this denominator is a 5 and a negative 3. So I'm going to draw a number line. Positive 5 and negative 3 ruin it. So I cannot have a 5 and I cannot have a negative 3. Now here's the deal. Do you see any radicals or anything? Nope. So that means everything is going to work except those numbers. So my domain for number 14 is going to be down until I hit negative 3, or between negative 3 and 5, or 5 and up. And basically, see there's 1, 2, 3 solid lines. That means there's 1, 2, 3 sections I should be writing. All right, let's talk about 15. Is this a fraction? Nope. Is it a radical? Nope. So this domain is easy peasy. It's all real numbers. All right, in 16, we have both a radical and a fraction. So step 1, I'm hoping you factored your denominator. So I got x minus 9, and that's all inside a radical, right? So the first thing I'm going to do is look at this, draw my number line, and I'm noticing that 9 and 4 would ruin it. So I'm going to put x's. And the reason why I'm putting x's instead of solid dots is because it's in the denominator. So basically, anytime anything's in the denominator, you're putting x's. Now I'm going to test. I'm going to test because there's a radical. So let's try 10. If I plug 10 into this, I get 1 and 6, right? Which makes, can I take the square root of 6? Sure can. So I'm going to go like that. Now plug in an easy number between 4 and 9, maybe 5, right? So plug 5 in. It's 5 minus 9, negative 4. 5 minus 4 is 1. That's the square root of negative 4. Oop, I can't do that. I'm going to put a big X. And then pick an easy number smaller than 4, maybe 0, right? 0 minus 9 is negative 9. 0 minus 4 is negative 4. Oh, we can definitely do that. So there we go. So the domain now is going to be negative infinity to 4, soft bracket because it's an x, or 9 and up. Okay. finally, I'm going to end on 3 simple ranges. We're going to do a lot more ranges another time. But let's talk about these. When you think of range, what you want to think about is what the picture looks like when you graph it. So take a look at this, 2x plus 1, right? What would the domain for this be? I'm hoping you're thinking the domain is all real numbers because it's a line, right? It's not a fraction or a radical. Now, the fact that it's a line, what would it look like if we graphed it? Right? For me, right? If I graph this, it's going to hit at 1 and be diagonal, right? Range is how low to how high, right? Well, this goes down forever and it goes up forever, so the range is all real numbers. Okay, let's talk about this one. Always do the domain first. What would the domain for this one be? Well, all real numbers, right? It's not a fraction or a radical. Now, to do the range, we want to think about what it looks like. Now, if I covered that up, what does the graph of x squared look like? And I'm hoping you're thinking, Stuffy, that's easy. It's a parabola. So it's a parabola that hits at the origin. So this is y equals x squared. X squared minus 3 means I would take this picture, right, and shift it down 3. Do you remember doing that last year? Right? This means the graph would be shifted down 3. So what would the range of this guy be? Well, how low do we go? It goes down to 3, but it goes up forever. So this is a situation where it's a little easier to find the range because you know what these pictures look like. Now what I want to do is do one where you might not know what the picture looks like. And that's really why we need domain. So take a minute, pause me if you need to, and see if you can figure out what the domain of this guy is. We'll start there. Okay, so I hope you pause me. And I'm hoping you started off with -4 would ruin it. So I'm going to put a -4. It's not a fraction, so that means I can make it a solid dot. Now I'm going to test around it. I'm going to plug in a number bigger than -4, like 0. 0 plus 4, right? That works. And plug in a number smaller than -4, like -5. Oh, that's no good. So that means the domain for this thing is solid bracket -4 to infinity. Okay, now we have to find the range. And this is a graph you probably don't know what it looks like. And we didn't use calculators for this. I mean, everybody take this quiz without a calculator and just use this to help them. What you're going to do is make an XY chart and use your domain. That means we're going to start at -4 and plug in numbers that slowly get bigger. And let's see what happens, right? Plug -4 into this, right? I get radical 0, which is 0. Okay, then I'm going to plug in -3. I'm going to get 1, which is 1. Then I'm going to plug in -2. And that's approximately like 1.4 and change, right? Then I'm going to plug that in. That's about 1.7. Plug in 0, right? What do you notice is happening with these numbers? See how they're getting bigger? If you want to, after you've done a bunch, jump. Let's say we do, I don't know, 5. What's the square root of 9? 30, right? Jump higher. What if we throw in 10? Right? But if you notice, look at the radicals. Everything is getting bigger. So what's the lowest number we hit? And then the numbers keep getting bigger. So the range here would be the lowest we went down to is 0, but we keep getting bigger. And if you were to plot this out, just so you can see what it looks like. 1, 2, 3, 4. Then we'd have negative, right? -3, 1. I'm going to just do 0, 2. Okay? 1, 2, 3, 4, 5 would be 3. Look what this graph looks like. It would be like that. And that's what and all radical graphs look like this. All right, so I'm going to stop there. If you notice along with this video, I have a couple different assignments posted. What I would do is do one assignment at a time, and then take a photograph or take a PDF of what you did, send it to me so I can look at it and make adjustments before you move on to the next assignment.